Okay, so completing this, partial of 1 over y with respect to y is negative 1 over y squared. And then we have our e to the x over y. And the partial with respect to y of x over y, we've already seen is negative x over y squared. So it'd be plus 1 over y times negative x over y squared, e to the x over y. And then we can factor out the e to the x over y, and then just do the algebraic simplification here. And actually, we could factor out a y squared from the denominator, couldn't we? So if we didn't factor out the y squared, though, we would have then negative 1 over y minus x over y cubed times this. Then we say, oh yeah, I can factor out a y squared, which I didn't write here. 1 over y squared, right? Which is going to give me then, write it out this way, negative y squared, negative I'm debating. Yeah, well, I mean, there are other ways to do this. I could put these over common denominator, y cubed, factor out the y cubed. That would probably be the best rearrangement. So I'll write that out in a minute. But I'm going to factor out the negative. Okay? Okay, does that make sense? But then I see that I've got this 1 plus x over y, which I really want to express as y plus x over y, common denominator. Okay? And that just becomes then negative y plus x over y cubed e to the x over y, which is the simplified form I think you'd be most likely to see. Okay? So if you're looking at the back of the book, you would need to be able to put it into any of these forms, but this is the simplest. And you could see that coming maybe when you look at this. You see you're going to still have a denominator over here. So you go ahead and put this over y cubed. So you'd have y over y cubed minus x over y cubed. You factor out the 1 over y cubed and get this more directly. Okay? But there it is. And again, the process of doing the partial derivative, I want to emphasize, you have to be very careful to apply the rules one at a time and very meticulously. Especially since, you know, this is the first time in second semester applied calculus that we've done much of anything with derivatives. So, you know, everybody's bound to be a little bit rusty. So you have to be doubly careful. You know the rules. Everybody knows the rules. But it's probably been a while since you had to apply them in more complicated situations, okay?